Hello and welcome to C++ Weekly. I'm your host Jason Turner, available for code reviews, contracting, on-site training. On-site training is definitely becoming a thing again right now, and my schedule is starting to look more interesting. So if you are interested in on-site training for your organization, I suggest that you contact me as soon as you possibly can. And while we're discussing the channel and supporting the channel, be sure to check out the awesome t-shirts that I have added. There are links to those in the video description, as well as my C++ Best Practices book and my puzzle books. In this episode, we're going to discuss a C++ 23 feature that I just learned about. All right, so this one really slipped in under the radar for me. I happened to be browsing through the functional header here on CPP reference, and I came across bind back, which says it is a C++ 23 feature. Now, interestingly, bind back isn't actually mentioned anywhere in any list of C++ 23 features that I can find. So it's entirely possible that it's not actually a C++ 23 feature, and someone mistakenly added it here to CPP reference, but regardless, it's a super handy tool, and it was actually very simple to implement, and I thought I would show some of the possible use cases for it. So I have put together this handy little tool that's just a struct called point, and it has a couple of functions like a displacement function and a operator plus and a print function, just to give you an idea of what this thing is doing. And so we can create one of these and do something like print this out just so that we can get, well, the value of it, which is not a very complicated thing here. And we see 42, 24. This is pretty handy with lib format, although, you know, we do have to be aware of the fact that it takes a whole lot of braces to get it to do what we want, but that's fine. What my immediate first thought was with bind back is that I could somehow bind the parameters for a member function call while leaving the actual member available. So if I were to create a couple of these point objects, I can do something like so what I've done is I have just created a helper that binds all of the last parameters, not any of the first ones. So it binds basically however many are left over at the end of the function. And now I can do something like this, where I have displaced this object P1 by 1 and 2. And as we can see here, I have in fact added 1 to the x value, and I have added 2 to the y value. And I can call this as many times as I want to on different point objects. And it's kind of cool, but you might be thinking, why in the world would you want to do this? Now, my first thought was this would be outstanding for algorithms. So I have in fact created a couple of examples here that make use of this bind back in algorithm scenarios. So I have this handy helper function that returns a vector of these points 1, 2, 3, 4, 5, 6, and 42, 78. I call this here on line 38. And then I am calling the for each algorithm, and I say for each of the data elements, I want you to use this bound back displace of 6 by 5. So I can just iterate over each of these things and add 6, 5 to them. And then I can use another for each to print out all of the elements. And as you can see, there's another ranges example waiting in the wings right below this. And we can see that 1 2 plus 6, 5 equals 7, 7. So we can see that I have in fact added 6, 5 to each of these things. Well, then I thought, well, it would be kind of cool to do this properly with ranges and a pipe and see what the possibilities are. And I'm not 100% convinced that this is the best way to do this, but it seems like a way to do it. And perhaps you will find this more readable, perhaps you will not. But in this case, I am calling getData, and I am piping that through a transform view. So it's not actually modifying the data that was returned, it's creating a lazily evaluated view of the data that was returned. And then I call this bind back function, and I pass it standard plus. Now, standard plus is just a little algorithmic helper here in the functional header that gives us something that knows how to call the plus operator on any two objects. So I say, take the left-hand thing and add it to this point, 7, 6. So perhaps more readable than an embedded lambda that does the same thing, if you're used to reading code like this. And we're adding 7, 6 to each of these values, which is why we get 8, 8, 10, 10, 12, 12, etc. And then I am using a standard old ranged for loop from C++ 11 to go ahead and print each of the elements in this getData. Might have been able to just pass that through for each to have accomplished the same thing as well. But I want you to kind of just think about this next time you find yourself using algorithms and ranges and such, that if you do have classes, you can just pass member function pointers, or you can use helpers like bind front and bind back to make these things accessible in a readable way to your algorithm users. So on that topic, let's go ahead and scroll up here and take a quick look at what I actually did to implement bind back, which of course is implemented with a lambda, and it's taking advantage of, well, a lot of lambda features that are from C++ 20. I have a function called bind back that takes the callable and the set of parameters that you want to bind. And then I am doing a generalized lambda capture here, saying that I want my own copy of the func that is forwarded. And then I want to do a variadic expansion of the param set. And I want all of those to be captured in the lambda by forward as well. So we avoid making as many copies as possible. And then I am doing an explicit template parameter for my lambda that is being returned from this function, because it needs to have its own set of parameters. Now, this is what has been returned. It is the lambda. When the lambda itself gets invoked, I call standard invoke, and this is a helpful helper in the case that I was passed a member function pointer. So I call the member function pointer or free function or lambda or stood function or whatever has been captured here. And I pass it the set of all of the parameters that were just passed during the invocation, followed by the set of all of the captured parameters. So all of the parameters that are sent during the invocation are the ones that fill in first, and then all the remaining parameters, the bind back parameters, are the ones that are filled in last. And I do a return here. And if you saw the episode on decal type auto, I just realized I probably should have done this. Wrong location. I need this decal type auto to be here at the end of the function lambda that is being returned from the function. So there we go. So now at decal type auto, to make sure that the return function properly forwards out the return value of calling this invoke. Quite readable, right? Well, I'm sure there's a fair number of you that don't think this is readable, so be sure to leave a comment about that so that we can get as many comments on our videos as possible. And thanks for watching this episode of C++ Weekly. Be sure to subscribe, like, comment.